Hey everybody, this video is going to cover the 3D printing I've been doing for 3 or 4 years now. I think it's been 3 years or maybe 4. But as many know, I love to dabble in doing very scale 3D engines for the RC world. I used to sell them online and now I only do them custom, like maybe 1 or 2 a year. I do them for myself all the time, but I've had a lot of people say, you know, what's it take to be able to make these 3D printed engines that are scale for model aircraft or for a museum. I've produced several now for people that are going to use them on aircraft that goes in museums, and one for a replica of the Spirit of St. Louis for a gentleman. So what I want to do is I want to talk about the 3D printing side of it, and then talk about how you design the engine, and then how you basically get an engine that looks scale. So first thing I want to talk about is the learning curve of learning 3D printing. It is not, I'm not sure how to say it. If you know how to use a jigsaw, if you know maybe how to use a lathe, if you know how to use your hands, and you know how machinery and equipment works, you can definitely learn and conquer 3D printing. I got into it a year later than I wanted to because I was terrified of it. I didn't know what machines to buy. I didn't know anything about it, and I was just terrified because there's so much noise on the internet about 3D printers. So the learning curve, I would say, is a couple of months for you to really get good prints. Now, you can buy a 3D printer, set it up, and print some of the models that come with it, and you should be able to print those virtually perfect within a week or within hours of having your 3D printer work. It depends on the type of 3D printer you buy, because I am in love with the Prusa 3D printers because they have self-leveling beds, which means basically as the nozzle goes around, it knows exactly where it is in relationship to the bed that you're going to print your model off of. Okay? So let's talk about what printer to buy. Like I said, I am very, very biased toward the Prusas. I own 2 of the machines, and I have one right now set up with a 4mm nozzle, and the other, 0.4 millimeter, and the other one is 0.6 millimeter, and I'll explain a little bit later why I do that. And I literally on one machine have, I think, pretty close to 50 miles now of 3D material I printed on it, and the other machine I think is at like 35 miles of material I printed on it in those 3 years. So basically you need to look at the bed size you want. How big a model do you want to print? What is your budget? What is your kind of learning curve? The neat thing about the Prusa is it's totally open source, so you basically get all the parts and you build it yourself. You can buy a fully assembled. I think they charge $200 more for the fully assembled. But what's really nice about the Prusa one I use is there's a bazillion forums out there. There's videos on YouTube, some great tutorials on YouTube. The customer service is really good. So I don't want to talk about other 3D printers. I know there's 4 or 5 other pretty good ones out there, and I'm sure with this video people are going to post below what they like. But for me, the Prusa has just been absolutely rock solid. In those 3 years, the only things that I have had wear out, I've had a couple of the cords that go from the heated bed to the power source that drives the heated bed to heat it up. I've had a couple of those connectors get hot and kind of burn up, and I had to replace those. I've not had a belt fail yet, but now I will, knock on wood. But yeah, I mean, I've had virtually nothing really go wrong with my my 2 machines. I guess the whole thing is that once a month I kind of go through and do a maintenance on them to make sure the belts are tight, make sure nothing is starting to bind. So I think one reason mine have lasted so long is because I'm literally every month doing some just preventive maintenance on them. So let's kind of dive into the nozzle sizes. You can get really small nozzles. The problem with that is any dust or materials in the air can get on your filament as it goes to that nozzle and clog that nozzle. So the smaller the nozzle size, the more chances you've got of it clogging. Now, I use some little foam rubber things on my filament to keep all the dust off as it goes into the heated head that extrudes it. The thing is and I'll dive into it a little bit more, is the environment you have set up for your printer makes a big difference. If you're in a real dusty area, that's not a good place for a 3D printer. And most modelers have dusty areas. So the nozzle sizes, 0.4 is the size that my machine comes with. They sell a 0.35, which is, of course, smaller, and it's really nice for detail. But the smoothness of your model comes from how thick your layers are. So you can normally print 80% of the nozzle width. So if it's a 0.4 nozzle, I think it's 0.32 is 80% of that, or something like or 0.34. But I normally, if I'm printing a part that's going to be not visually seen and it's structural, I'll print it with a 0.6 or 0.8 because it goes much, much faster. So think about this for a minute. I've had some 3D prints that take 24 hours with a 0.4 nozzle. With a 0.6 nozzle, it takes about a third less. Because your heights, the thicknesses of your layers could be different. So I have a 0.35, a 0.4, a 0.6, and a 0.8. Now the 0.8 to me is almost like squirting out toothpaste coming out of the end of the extruder. I only use that for structural parts that are going in an airplane to hold things together or something. I don't use that necessarily for my 3D printed engines. The heated bed, the reason you want a heated bed is the hotter the bed is, when you're laying down your material, the more it wants to stick to the bed. And normally I keep mine at 80 Celsius or 90 Celsius or 100 Celsius depending on the material. How fast is fast? So you many times will create a part and get ready to print it, and if it's got a lot of detail, you will print it in really thin layers. And you might print a cylinder for a radial engine, and each cylinder takes 3 hours to print. So you're going to spend some time printing that engine. I have printed engines that's taking 2 weeks to print all the parts. And that's running the machine about 16 hours a day. So you can't be in a hurry if you want detail. Okay? I mean, if you're building just a part to hold something together, yeah, you can print it, thick and fast. But if you're printing detail, you need to have the patience. So now you need to think about this. If you own a 3D printer and you're going to download parts and pieces from the internet to print, like frogs and Eiffel Towers and stuff like that, go at it. It's great for your kids, blah, blah, blah. But if you're going to create 3D detailed engines for RC aircraft, you need to know how to design that model. So I use Fusion 360. And the nice thing about Fusion 360 is it outputs the STL file, that's the 3D file, that has to go into a program that will then slice it up so that your 3D printer knows how to print it. And I'm going to dive into that a lot deeper later on in this video. But what I want to talk about is the learning curve of Fusion 360. Again, I had worked with 2D CAD for many years. I had worked with 3ds Max doing some modeling, but I had never owned a mechanical type engineering 3D program. Now, I can't afford SolidWorks or Inventor, but Fusion can be downloaded for personal use for free. And with Fusion 360, there are so many tutorials on the internet that, and now keep in mind, I also had a lot of experience drawing 3D using my 3ds Max. So I would say I already had a good lead on understanding how to draw 3D, okay? But I would say the novice, the person who knows nothing about 3D, could spend 6 months with Fusion 360, let's say a half hour, 3 or 4 nights a week, and pretty much master it enough to be able to design 3D radial engines or you know, other, you know, I've done Lycoming engines, I've done Cub engines, you know, so you, I've got a big Merlin quarter scale V12 I'm designing right now, but I can't show any pictures because the person who's paying it for me has a non-disclosure agreement with me. But you can basically draw anything you want once you master Fusion 360. But there are so many tutorials out there, and I'm begging you. There's a guy named Lars that's out on the internet that works for the Fusion 360 people, which I think is owned by Autodesk, and his videos are just absolutely fun and easy. Okay, now I've had a lot of people say, could I help them learn Fusion? The tutorials on YouTube are so much better than I could ever teach you, so go find those. Okay, so now let's say you own a 3D printer, you're mastering Fusion 360, and you're like, Damon, what the hell's going on with all these different filament types? There's so many people out there with such strong opinions. Well, I'm going to tell you my strong opinion. There's a material called PLA. Everybody's like, oh, that's the only thing you can print with. Not if you're going to print a black engine and put it in the sun. The sun will create enough heat that it will droop and melt your model. Okay? I love ABS. Now everybody goes, oh my God, that's the hardest stuff in the world to print. You know, everybody, I don't know what it is about me, but I don't like to print anything but ABS because ABS prints perfect for me. Now, there's a couple of things you need to know about ABS. You need to use some kind of glue on your table, on your heated bed. Now, most people say, oh, use hairspray. I've never liked hairspray because it sprays everywhere. I don't want to be spraying a mist or a spray on my machine where the overspray is going to go everywhere. So I actually use the Elmer's glue sticks. Now, there's 2 types of glue sticks, and you need to buy whatever Elmer's has and finds out which one works, because one, it won't stick at all. It's like waxing it. The other one, it sticks like epoxy. And the nice thing is it's water soluble. So you spray water on there, heat your bed up to 80 Celsius, and then just wipe it off with a paper towel. So you've got to use a good glue with ABS. Another thing about ABS is if you've got a long, thick part, as it prints, that ABS will cool and it will warp. So you need to keep your bed temperature at like 100 Celsius if it's a big ABS part. Okay, because it will warp if you don't have enough glue to hold it down to the bed and you don't keep your temperature up. If you have your temperature at 80 Celsius and you're printing some little like rocker arms, you're fine. If you're creating a block of a V12 on there, it may warp and pull up and you got to throw it away. So you got to keep the temperature up. Another thing I'm going to talk about also with using ABS is having a heated chamber. I'll touch base with that in a minute. So then there's ASA. Now look, everybody, I don't know how to explain this because of my personal love for ABS. There is a material called ASA. And this sounds harsh, but there's some people out there saying that you're a fool if you use ABS. Why would you ever use ABS? ASA is not affected by UV light in the sun. That statement is totally true. ASA is designed that it could sit in the sun for 10 or 15 years and not be affected by UV light. But here's my rub with that. I did a video 3 years ago now where I printed some ASA parts and ABS parts, put them in the sun. They've been out there for 3 years now and they both look brand new. The thing is that ASA will never deteriorate because of UV light. ABS will after 10 or 20 years, okay? It might be less than that. I need to check it this year and see how brittle it's gotten. But for us modelers, the difference between ABS and ASA is only in money. ASA is a little bit more expensive than ABS, okay? Then you have PETG. I don't like PETG because you can't smooth it. And I'm gonna talk about smoothing here in a minute, okay? But PETG is a strong, higher temperature in most cases, material that I use for structural components, Okay, if I need something I'm going to use as a structural component, I use PETG. Then we have carbon fiber, which everybody in the world, the first time they buy carbon fiber, think I'm buying the strongest material there is. It's not strong, it's actually weaker than ABS. I'll tell you why. If you take epoxy resin and mix sand into it, and then test that epoxy resin, the sand actually creates weakness through it because it's creating voids. I mean, it's creating particles in it that aren't as well bonded as the pure epoxy resin itself. So carbon fiber materials, either carbon fiber ABS, carbon fiber I think PETG, carbon fiber is put into a material. I think ASA carbon fiber too. The carbon fiber makes the part really, really light. That's what's beautiful about it. But if you try to smooth it, I'll talk about smoothing in a minute, it's rough because you got carbon fiber little chunks in there. Now there is a couple of companies that's trying to do a continuous carbon fiber strand in the ABS as it's printing. The problem with that is that that's a very particular machine that knows how to start and stop that strand of ABS filament that's in there, because when a 3D printer is working, it will start and stop in different places. Well, if there's a string in there, when it goes to drag it, it's not going to work. So, and I've only read a little bit about that. I still don't understand how that works, but I just don't want to give you misinformation. And then there's PC, polycarbonate. Normally I'll use an ABS PC blend because my machine will only, the heated nozzle, my heated end, will only go to 300 Celsius. Most PCs need in the 340 to 350 range unless it's mixed with a blend. And I use PC ABS. Now the reason you want PC in a material is because it is got a much higher temperature. If you got it close to something hot, PC won't melt as quick. Plus it's really strong. Okay, now I'm going to talk about smoothing. And I want to give a big warning here. Okay, and I don't know how to get this across to you more. I've gotten more emails trashing me on how I smooth my parts. I've been doing it 3 years. Keep in mind, everybody, if you don't do this right, it's dangerous. Okay? So what I did was I took an aquarium, I made a plexiglass lid, and I put 2 brushless motors in it. Brushless do not create any sparks. Brushed motors create sparks. I then create a little, basically container of acetone, and I put a paper towel wick in it, almost like a candle wick. Okay? The fans blow the acetone around in that, and if you set the ABS part in there, within about an hour, it will look like a molded part. There are no lines. Okay? There are no printed lines left. So for doing scale, I will put it through what I call the acetone vapor bath. Now, I'm always present when I do that. I've got 4 fire extinguishers around it. I did do a test in my garage where I set the setup and threw, well, basically not a match, but an Estes rocket igniter, and it did ignite, but it all burned off very quickly inside. And then, because there's hardly no oxygen in there, is my guess. I don't have an oxygen meter in there, but I did ignite the vapors in there. And I was scared crapless when I did it because I thought maybe it's going to blow this. Now, most aquariums are made out of like acrylic plastic or something nowadays. They're not glass. But I was afraid it was going to blow it all over my garage. So I did stay out of the way. I made sure I had fire extinguishers, a bucket of sand. I can't remember everything I had. But I did put a rocket igniter in there and ignited the acetone gas. And it burned off with a really cool color in about 4 or 5 seconds. And then it just extinguished itself because there was just no oxygen to feed it in there. It's an airtight container. Now, I did not do a video of that because I don't want people on the internet reenacting that. So look, if you're gonna, now there are some people that take an acetone bath, like liquid. They'll take the part and dip it really quick and then sit it. That works pretty good also. You might have to dip it a couple of times to get the way you want it, but I needed a way to smooth a lot of parts quickly. So I could normally get 40 or 50 pieces in that aquarium and smooth them all in an hour. But I don't know how to stress. I know 1 or 2 people that's made that same acetone vapor bath like I did, And it scares me because if you leave the room or, you know, to me, I treat it, guys, as if it's just volatile, okay? But I've gotten it down to a science, and knock on wood, I've never had any issues. But fire extinguishers, and always be present when you're doing it. Keeping filament dry. There's a big thing on the internet that you got to keep your filament completely 100% dry. You should if you can. If you're in a dry basement, my ABS does okay. If I notice when it's printing, I see little bitty microscopic bubbles popping up, I'll take the ABS, set my oven at like 120 degrees, put it in there for 2 hours, dry out the ABS, and I'm good to go. Do not get above like 150 or 60 degrees because you'll start melting everything in there. Heated chamber. One of the reasons I created a heated chamber around my two machines was if I can keep it about 140 degrees in that chamber, I have a lot less shrinkage and warping of parts. Okay, it helps a lot. I've been told you really want to be 150 to 160 degrees, but the fear of that for me is I'm heating up my PC board on the 3D printers. I'm heating up all the parts in the 3D printers to 150 or 160 degrees. To me, that's just too hot. I've done a lot of research that says all those parts are good up to 200 degrees, but it just freaks me out. So I keep mine around 130 degrees, 120, and my parts come out great. Now we're going to talk about the slicer program. The slicer program is where you take a 3D model, you output it as an STL file, then you take that STL file, put it into a slicer program, and this program is where you can say how dense you want the part. Most of my parts are set at 25% density, so it creates a hollow part except for supports to hold it together. And then inside, and I can set how many layers, the thickness of the layers and everything. So the slicer program for me is Simplify 3D, I think it's called, and I love it because it just gives me so many parameters. You do have to pay for that program. Okay, so now let's talk about the design. And this is where my biggest learning curve was. This was the hardest thing for me to figure out, is how do I build a part in 3D that a 3D printer is going to love to print that part. Now look, you can basically take any part and with supports tell it to be printed and it will print. But I have found out that there are certain ways to do it that is just much more, looks just much more better. But also think about this for a minute. The cylinder on a engine has cooling fins. If you try to print that cylinder vertical, you're going to have some kind of support in between each one of those cooling fins and then remove it. So it's better to cut the cylinder in half, lay it on its side, and then build it up off the table. I mean the 3D slicer program table, because basically that table in there is what your heated bed's going to be. So you need to really understand. Almost like a pilot flying into a storm, you want to be ahead of your airplane. When you're designing a 3D radial engine, you want to be so far ahead of the curve. You really want to be ahead of the curve. You also need to understand your layers that you're going to build the model in. So with Fusion 360, you need to really understand how to use that program. But now we're going to back up. You have just decided you're going to build a radial engine, let's say for a Stearman. Which, by the way, one of the reasons I hated 3D printing engines for people is the Stearman originally came with a big seven-cylinder engine motor. But a lot had been converted to having a 9-cylinder. So when somebody would say, I need a Stearman engine, I would tell them what it is. They wouldn't listen to me and say, yep, that's what I want. I would send it to them. They're like, wait a minute, this isn't a 9-cylinder. And I just got so frustrated that people wouldn't look at what I sent them. I sent them a freaking document of what the motor would look like printed. And they said, yep, that's what I want. And then they get it and they're like, this isn't a 9-cylinder. So that blew my mind, okay? But the most important thing you're going to need to know is documentation on that engine. You need to see every view. Many times you can go on the internet and buy. Like I bought the how do I say this? I bought the blueprint drawings to the J5 engine that went in the Spirit of St. Louis. So because I was asked to make one of those for a basically a museum type project engine. I've just been contacted to actually make a half scale J5 for a guy that's going to have it in a museum. So when I went to build that motor, design that motor, I couldn't find a lot of stuff on the internet. So I finally just typed in, you know, the blueprints for it and found out somebody sold them. And I bought the entire blueprints of that engine. So right now I own, gosh, probably blueprints for 6. Well, I don't want to say I have the full blueprint sets, but I have 6 or 7 radial engines now. Then once you get your documentation, you need to look at that engine and say, how am I going to cut it up into parts that I can print? You know, the engine crankcase, there's going to be a front and a half most of the time. The cylinders, if you're going to print the cooling fins right, you want to cut that in half and have a front and back. If the engine's going to go on a model airplane, you need to make sure that the cavity inside the crankshaft is big enough for your electric motor. Now I say electric motor because 98% of the people I sold these scale engines to put them on electric airplanes because you didn't have to have a big cylinder, excuse me, of a 2-stroke sticking out the bottom of it. So you need to design it to run whatever electric motor you're going to have to make sure it fits in that crankcase. Sometimes you have to fudge and make the crankcase a little bit bigger. You have to decide if you're giving up enough scale that matters, okay? And then you got to say, how scale is scale? Me, I've actually had real studs sticking out of crankcases with the little nylon nuts screwed on it to show it as the nuts that hold down the cylinder. So, yeah, I mean, it's you can get as detailed as you want. It's just, are you willing to take the time to do that? How many parts are you going to have in your engine? Some of my engines had 147 parts. And now, I didn't draw 147 parts. You know, like if it's a Larone engine, all the rocker arms you draw once and then you print it 7 times. Okay? So you won't draw 147 parts. You might only draw 40 parts. And then if it's a 9-cylinder engine, you'll have 18 valve covers. Okay? Can it be supported well when you're printing it? You need to really think when you're designing a scale engine, how is that going to be printed on that bed? The V12 I'm designing for a guy right now, it actually is a lot harder than the J5 is because the way the real, yeah, I'm not doing a Merlin V12, I'm doing the Allison. Yeah, the Allison V12, the way the crankcase goes together and stuff, or it was the Merlin. I can't remember right now which one I'm printing now. I just know that there's 2 parts at the bottom of that crankcase that is really hard to design in 3D. I already touched on warping, and you may want to have a heated chamber if you're doing a scale big engine block. How hard is hard? So you need to ask yourself, are you willing to fail quite a few times, and how short is your fuse? Because there's nothing worse than to start a 3D print and you see it going great, and you walk by it 10 minutes later, oh, okay, this is working great. You walk by it 3 hours later, oh, it's looking great. You walk by it eight hours later, oh, it's working great. You walk by it 16 hours, oh, it's great. And then you walk by the 17th hour and it's just completely screwing up. You feel robbed. You feel robbed. Normally what happens is if a big part starts to curl up, it's starting to happen once it's a big piece of ABS, and then your printer up there, your extruding head, is not seeing the right height because this is coming up and everything starts getting squished out and flat, and you just stop the print, take that ABS, throw it across the room. That's if the trash can's across the room. And then you start all over. And that has happened to me many times, and the early part. Well, even happens to me once in a while when I'm doing a custom job. Once you've got that completely designed, you need to have basically a way to manage your files. How are you going to manage your files? And what I mean by that is your cylinders are in a folder, your crankcase is in a folder. You want to create a file system so that you can find all these parts and pieces. Because if you build an engine that's got 40 or 50 parts, and that doesn't sound like that many, considering when you print it, you might have 150 parts. But still, those 40 parts, you will decide when you slice it to have different thicknesses. So like the crankcase, I might print with a 0.6 millimeter nozzle. The rocker arms, I might print with my 0.4 or 0.35 because I want it to be very detailed. So you need to have a file structure that won't drive you nuts. Today, I still go through that. Like when I first started this 3 years ago, I've got a couple of engines I designed for people, Piper Cub engines, that when I look at the file structure back then, it takes me forever to figure out, you know, what the different parts and pieces are. I mean, I print the gaskets. So just so you know, when I print a 3D engine, I actually print the gasket. So when you see the valve cover on there, you see a different color valve gasket on there, okay? Now you gotta say, I got my model completely printed. How's it going to stay together? Okay, there's not a lot of glues that are really good for ABS. Now you can make your own ABS slurry by mixing some acetone and ABS together and getting a good glue consistency, and that works okay. But for me, I use either CA or I use 5-minute epoxy. Okay, if it's going on an electric model, you don't have to worry about it. If it's going on a museum type model, you don't have to worry about it. If it's going on a gas banger that's just sitting there vibrating the crap out of itself, you may want to actually, when you put the cylinders in the crankcase, drill small 256 holes through the back and run a screw into that cylinder to make sure the cylinder can't break the glue loose. And then you got to paint it. And I usually paint the ABS with any of the store-bought Testors paints, Krylons, any of that stuff. So hopefully you found this informative. Hopefully if you want to dive into this, you just got to dive into it and learn. Okay? I guarantee you, if you stay with it and don't get frustrated, you can virtually become an expert in a couple of years. And I know that sounds like a lot of time, but when I look at some of the first engines I printed, and then I look at some of the engines in the end that I printed, it is not hard, it just takes time, okay? And you need to have a very long fuse. If you got a short fuse, you probably don't want to do this because there will be some real frustrating moments, especially when you print something in the last 20 minutes of the print, it goes bad. So look, everybody, I hope you found this informative. Keep the emails coming to me. I probably had 20 emails, people asking me to make this video on 3D printed engines. Right now, I'm not taking any work. I'm not doing this video to try to get people to reach out to me because I do not want to ever sell 3D engines online anymore. It was just too hard to keep everybody happy. I'm still taking some custom jobs, but not until 2021 now. And I got a really cool, I can't remember the name of the bomber, but it was a World War I bomber that had 2 Lerone engines in it. And I'm going to build this summer 2 huge Lerone engines for this guy. And I also have another guy that's going to do a smaller bomber that has Lerone engines. So I've got 4 Lerone engines to do this summer. I've got the half-scale J5 that I'm going to start this Christmas. And I've got the V12. And I have 2 Cub engines, half-scale Cub engines. And that's all I'm going to do this summer, everybody. So now, if you're one of the people I promised you an engine this summer and I didn't just mention your engine, I'm still, if I've promised you an engine this summer, I'm going to do it. I'm finishing up 2 right now. Just keep in mind, everybody, I've got an awesome family. I've got an awesome full-time job. These engines are only printed in the evening or on the weekends. And I'm trying to build this ultralight right now. So And I've got my big airplanes that I'm taking to CEF and about 5 other fly-ins this summer. So I just don't have time to do these 3D engines for everybody. And I hope you all understand that. But please always reach out to me, because if you could wait a year, I would love to help scale modelers. I mean, I do want to say very clearly, if you're a scale modeler that is building a pup or building a Sopwith or building something extremely scale, do not be depressed. I will still figure out how to build you an engine, but it's going to be a while. So everybody have an awesome day. Hope you enjoy these videos. Keep the emails coming, and rock on, everybody. Thanks for watching.